Hello and welcome to my VOSTA, Predicting Neonatal Outcomes using Machine Learning, also known as NOML. My name is Dr. Raman Sharma. I'm a community paediatric consultant in Swindon. So I want to start with a question. What connects complex hydrodynamical cosmological simulations like this one called Illustrious TNG? This is a simulation of about 300 megaparsecs of the universe evolving from the Big Bang to the current day. What you're seeing here in the top corner is a galaxy gas density and then stellar density and a mosaic of lots of galaxies. What connects that to extremely preterm neonates? Now, if you can answer that, I'll be very impressed. But the answer is data. So data connects both of these in terms of what they generate. So galaxies, when imaging them, generate lots of data, as do neonates when they're on the ward. But also understanding them, generating new insights, requires lots and lots of good, solid data. Now, the thing about neonatal care is that the majority of that data is entered on a Zinkel EPR called Badgernet, which is quite useful. You can extract that information for your unit fairly easily, and it's very detailed and fairly robust. A common question that parents will ask is, when can we take our baby home? Now, often the answer is, well, at the equivalent of 40 weeks gestation. Now, that answer is good, but when you actually look at it, it doesn't really predict the discharge date very accurately, which can cause a lot of distress. So what I did was use a machine learning algorithm rather than a neural network. Neural networks are much better at dealing with millions of data points, whereas I was dealing with tens to hundreds of thousands of data points. And I used that on this data set to glean insights using appropriate variables. I saved the model and deployed it via Streamlit, and had about 4,500 babies to test it on. So when I used that model and trained it and tested it on the test arm of my dataset, my results are much better than the more simpler prediction using gestation. The R squared is 0.89 and the standard deviation of the residuals is only it's less than a week. So when I use this model to predict the discharge date, I'm within a week, which is not bad. Now, that was only using a single unit dataset, and that provided clinical value. The national Badgernet dataset holds about 1.7 million neonates. So with resources and investment, these sorts of models can be used to glean lots of different conclusions and insights into care from datasets that big. Now, if you want to use my code, feel free to fork it and play with it. The web app is also there that you can use to upload anonymized Badger data. Thank you very much.